The topic is permutations of a given string. So first of all, we'll understand what does it mean by permutation. Then we will see the method how to find permutations. There are more than one method. So in this video, I'll show you one method. Then in the coming video, you can find the second method for finding permutations. So first of all, let us understand what does it mean by permutations. See, there is a string here. Alphabets A, B, C are there. Then we want all permutations, means all arrangements of A, B, C. So like if A, B, C is given, then one of the permutation, one of the arrangement is A, B, C. Then A, C, B, this is the first one, this is the second one. Third one is B, A, C. Fourth one, B, C, A. And fifth one is starting with C, then first A, then B. Then sixth one is starting with C, first B, then A. So there are total 6 possible arrangement of those alphabets of a string. So how many, if there are 3 characters in a string, then how many permutations are possible? 3 factorial are possible. It means for n, how many possible? N factorial are possible. So we want all those arrangements. Now how to get those arrangement? So for that we will devise some procedure, or we will devise some logic for generating all those permutations. So first let us do some board work to get the idea how we can get those permutations. So here I'll do the board work. See, let us say this is the starting point, and next the first alphabet, I'll say first alphabet A, the next alphabet B, the next alphabet C. So here I got the result A, B, C, if you come along this one, right? So this is, I am forming a tree, right? So from here, go back. So after that B, there was only one alphabet. Okay, go back to A. When I am on A, I can go on B as well as I can go on C. So B already I have taken. So let us go on C. Then from A, I have gone on C. So what is remaining? B is remaining. So then what is the result? B, C, A. So this is B, C, A. So I got 2 different arrangements. So I can show these arrangements in the form of a tree. Yes, then after C there was only one letter B, then after A, B and C both are over. So let us go to next letter B. If I start with B, next letter should be either A or C. So first I will take A, then I will take C. So this is another permutation, that is B, A, C. So that is B, A, C. Then go back. After A, only C was left. After B, C is possible. Then next is A. So B, C, A. This is B, C, A, another permutation. So for B, A and C both we have tried. So let us go back to the main starting point and take the next letter C. So now I am starting with C. So what are remaining? A and B. So first I'll go to A, then B, then it is C, A, B. Or else I'll go back, and from here I will take first B, then A, then it is C, B, A. That's all. 1, 2, 3, 4, 5, 6. These are 6 permutations. Yeah, here I have to write A, C, B. Yes, this is A, C, B. So I have total 6 permutations that are what we wanted, right? 6 permutations. So this is like forming like a tree. So this tree is representing all various possible solutions. So this tree we can call it as state space tree. State space tree, where the leaves are showing us the results. Then one more thing we will observe about the tree. Start from here, go to A, go to B, go to C, go back, go back. So again from there go on to C. So this going back and again taking another route, this we can call it as backtracking. So this is representing backtracking. So we have learned one more term. So 2 terms, this is state space tree and this is backtracking. The approach is backtracking. And one more thing we'll learn here. See, from this A, B, C, what all possible permutations, all are shown here. Everything is explored here. So this is called as brute force. brute force. See, these are different terms. I'll explain you. Brute force means finding out all possible permutations. That is the meaning of brute force. How you do, it's up to you. Here we are using backtracking. So backtracking, if you observe, in this tree, we have gone on to A, then B, then C, then we got a result, then we went back, then back. Then we took another route. We have went back and taken another possible route. That's what is backtracking. These are the two things we learn. Now, the last and the very important thing is, see, whenever you have a procedure, in the procedure, if you have to go back and take another route, then those procedures can be implemented using recursion. Yes, recursion. See, we have to use recursion to achieve backtracking, and with the help of backtracking, we are performing brute force. So this looks like all same thing, but these are different things. Recursion is a recursive procedure. It can do anything. It can do anything. There are various forms of recursive procedure. But a recursive procedure which is trying to explore everything is a backtracking procedure. Right? And if a procedure is backtracking and finding out everything, then that procedure is called as brute force. So this can be done using loops also if you want, but you have to use a stack for using loop. So this is mostly implemented using recursion. So backtracking is implemented using recursion, and backtracking is used for achieving brute force or taking up brute force approach. Right? So these are the terms that we have learned from this example. Right? So the example is to find all permutations. Now we will work on the example. We will study this state space tree, then we will try to devise a recursive function which will generate all these things. So let us work on recursive function. For writing a recursive function, let us observe this state space tree. See, it is starting from here. And where are the answers? We are getting the answers at the leaf nodes. Yes, this A, B, C, A, C, B, so on. We are getting the answers at the leaf. As it is recursive, let us say it is starting from here. So this is the first call. This is the first call. This is within the first call. Within the first call, we are taking first letter. Then it is calling itself. In second call, again it is calling. So in second call, we'll take a letter B. Then the next call will take a letter C. Then it will go back to the previous call. Go back to the previous call. Then in this call, again it will call itself. So it means being on A, it is calling on B also, C also. Both it is calling. So when we have taken C, then we will take the missing one. Remember this, missing one. So we should know which is missing, which is not yet taken. So after A, we are directly on C. So B is missing. We should know which is taken, which is missing. It will take B. And at the leaf, it will print A, C, B. These are the three letters there with us. Right? So if you observe in the first call, it is going on first letter also, second letter also, third letter also. It's going on all. Then if I drill down to the next level, in the next level, leaving the first one which is already selected, it is selecting both B and C. Yes. So it means it is traversing through a string in each call and picking those which are not yet selected. And at the leaf, it is preparing a single string and displaying a string. So we need a few data structures here. Already we have a string, but we need to prepare the result, this result. So let us take a result. So we'll take an array as a result. This should be of same size, right? 0, 1, 2, 3. So in this we will be storing these alphabets A, B, C. Then we should also know which one is included, which is not included. So for that we will maintain a flag array. So I will call it as A, right? And this is 0, 1, 2, 3. And initially all these values are 0, means nothing is selected. Now I will trace this tree and prepare few strings and give you the idea. Then based on that, it will be a very small function. So I will write on the function also here. Let us first observe how it is working. Now let us trace this one. So for this, we need to start with the k, that k as 0. That is, in this call, k is 0. Right? So k is 0. For that we will take A, B and C. So we should know which one is taken, which one is not taken. And we have to scan through this string. For that we will take I here. So in the first call, k is 0. And here I is 0 right now. Now, in the first call, we will check whether this a of I is a 0 or not. Yes, it is 0. So we'll make this as 1, right? And write a here and call itself again. Call itself again recursively. So when it is calling again, it will call for the next level. So k should be on next location. So at this level, k is at 1. Then what about I? Now at this level also, I should scan through the entire string. So again start I from 0 only. Start I from 0. I 0, is that alphabet available? No, we have already taken. Then I plus plus. Is this alphabet available? Yes, it is available. So mark this as 1. At this place, B is there in the string. So write B, right? So I is now at 1. Then call itself again for the next level. Whenever you got a letter, call next level, that is k plus 1. So it has to call for the next level, that is for this alphabet, right? So now k is 2. At this level, k is 2. Now here also, it should scan through the entire string and take those alphabets which are missing. So it should take an alphabet that is missing so far. So again, I starts from 0. Check, is it available? No. Next one, I plus plus. Is it available? No. Is it available? Yes. So I is here, mark it as 1. And at this place 2, the letter is C. So take C. Right? So right now I is at 2 there. I is at 2. It has got the character. So again it should call itself. So this time again k starts from next letter, that is k plus 1. So it will call itself on the next alphabet. Now again I should scan the string. But no, check here. K has reached index 3. And in the string, main string, it is /0. Means k has reached at the end of a string. No doubt k is representing this string, but at the same place, if you see matching place, that is null character. Means we should not go further, or we should not process anything here. We have reached the end and we got the result. So at this place k, put /0 and print this one. So in the next call, printing is done. In the next call, when k is equal to 3, printing is done and we will not scan through this string. So this is one step I have shown you. We have reached the result for the first time. Now if you have understood this, then you can understand all other. Though I have to continue, I'll show you few more, than how it is working. You can understand it clearly. Now till here you should be clear what all has happened. This was the first call. First time k was at 0. This is for the result array, right? Then we got A, then we got B, then we got C, then we got reached the end. So we have printed A, B, C. Right? Now, once you have printed A, B, C, don't go further. Go back. Go back to the previous call. So go back to the previous call means where was K, where was I? Let us know. K was at 2 and I was also at 2. So K was at 2, I was also at 2. Then what to do here? What we were doing, scanning the string, continue the scanning the string, continue scanning. So before going to the next, make this as 0 and proceed. If you reach here, this is null. So finish scanning in this level, right? So finish scanning means again go back to the previous call. So in the previous call, where k was and where I was, k was at 1, I was at also 1. So what you were doing here, scanning through the string. So continue scanning. But before that, make this as 0 and proceed. So when you go back, make that as 0, right? Make it as 0. Then continue scanning. Okay, continue scanning means next I plus plus. Is it available? Yes, that is 0. That is 0. Yes, it has to be taken. So at this place, it comes to this one, right? See, k is 1 and I is 1. Here k is 1, but I is 2. Yes, k is 1 and I is 2, and this is available. So whenever a letter is available, mark it as 1, take that letter, call itself again for the next letter. Call itself again. So k is now 2. Then again start scanning the string. So in every call, we are scanning through the whole string. I starts from here. Yes. Is it available? No, not available. Next, I plus plus. Is it available? Yes, that is not taken. So make it as 1 and write B wherever this K is pointing, because this is B. So write B here. Yes, we got that letter B. So where I is pointing right now? I is pointing at 1. Yes. Then call again itself again. So if we have call again itself, K has reached null. So K has reached null means in this call print. Now this is printed. Now after printing, go back to the previous call. Where K was in the previous call? Previous call K was at 2. Then where I was at 1. Then what to do? Continue scanning. So but before that, make this as 0 and continue. Is it available? No, it's not available. Next, is it available? Oh, you have reached null. So we have finished with this level. Go back to the previous. Once you have finished, go back to previous. So where K was at 1, where I was at 2, K was at 1 and I was at 2. What to do? Whenever you are going back, you have to mark that as 0. Yes, mark this as 0. Then continue scanning. Next, that is null. So we have reached null. Then go back. Go back means which call now? This one, right? This one. See, we have finished this and finished this and finished this. So where K was at 0, where I was at 0. So K was at 0, I was also at 0. Then what to do? Make it as 0 and continue next. So make this as 0 and continue next. So I is here. Now I will show you one step that will be sufficient for you to understand everything. Now in this step we are scanning through next. So we are here now. So where is K? K is at 0. Where I is now? I is at 1. And is it available? Yes, that's why I am writing it. So make it as 1 and copy this at K. So this becomes B. Then call itself again. So K becomes 1. K becomes 1. I starts from again. So is it available? Yes. Make it as 1. Copy A here. Make it as 1. So I is at 0 right now. And copy A here. Then call itself again. K will be on next. And again start I from 0. Is it available? No. Is it available? No. Is it available? Yes. I is here. So make it as 1, copy that letter C. So K is at 2 and I is at 2. So yes, print BAC. So here you can see that it is BAC. Yes, we got that permutation. Now as we have reached null, this is null, so we have printed. Now do what? Go back. Go back where K was and I was. K and I both were at 2, so this is 2. Then what to do? Whenever you are going back, make it as 0 and continue. So there is nothing. So again go back. K is at 1 and I is at 0. So K is at 1 and I is at 0. What to do? Make it as 0 and continue. So continue. This is already taken. This is not taken. So yes, now we get C. So here it will be. So this is the second step in this call. So K is at 1 only. But so this will be selected and C will be written here. Then obviously A will come next. So that's how it carried on. Now let us write a function for performing this permutation. So here I will write down that function. So let us start writing the function. Void, I will write down the function name as PERM for permutation, and it should take array of characters, that is string it should take, and also it should take K, that is the call number, that is for result. You remember K is 0 here, K is 1, K is 2. So in every call it will be incrementing K and calling itself. Then inside this function we need these two arrays which must be permanently there. In every call they must be present. So I should declare them as static. So if you declare anything as static, then it will be available for all function calls. So I will take an array of size 10A and that is initialized with 0, and also I will take a static in character type array as a result, and this also I will call it as size 10. So these two I have taken. Now next, what I have to do? I have to scan through a string and print it. So for scanning through a string I need a variable I will take it, and here using a for loop I will scan through. For I assign 0 as long as s of I is not equal to null character I plus plus, scan through the string. Using a for loop we can scan through a string. Then while scanning, what we have to do? Every time check whether this alphabet is available or not. So where I have to check? If A of I If it is 0, means alphabet is available. If it is available, then what I have to do? Copy an alphabet from S to rest, right? So where? From I have to copy wherever K is pointing. Like suppose if I am copying this alphabet, right? So C I have to copy here. So from S of I, copy into rest of K. Yes, rest of K. Copy that alphabet, right? After copying that alphabet, inside A of I, mark it as 1. A of I, mark it as 1. The next step is what? Call itself again with the next value of K. Call itself again, that is I am calling the function name as perm, P-E-R-M, right, permutation. So S is string is as it is, but K plus 1. Yes, so this will call itself. So this is for loop, and this is all happening inside if. And when the function call is returning, I should make this A of I as 0 back again. So A of I as 0 back again. This is the step I was doing. And this all happening if A of I is 0. That's all. And this is the end of the for loop. So these are the things that are inside F. And that's all happening in for loop. Then one last thing. When we have reached K at the last, that is, it is null. At this place it is null. So what to do? Print. So that I will write here. If S of K is equals to null character, then printf result. Printf percentile S, print the result. Right? Then in result of K, mark /0 and also print the result. So printf result. I am just writing it as printf result. So this I have to do if. Otherwise, if it is not a null, then this whole thing should be done. So all this procedure is in else part, right? When we have not reached null, if it has not reached null, then do all this thing. If it has reached null, then print it. So that I have written it in the beginning. So this is the procedure. And if you want to call this function from main function, so I'll just write on here, if inside a main function, if you have a character string S and it is having letters A, B, C in that, then call this function PERM by sending S and starting value of K should be 0. It will print all the permutations. So that's all. See, this is the procedure. I have shown you the detailed working of this one. This you have to do it by yourself by using pen and paper. If you do it by yourself using pen and paper, then you can understand it clearly, right? See what I was discussing, just I was saying Ki, Ki. So this, once you put it on paper, you can understand clearly. Keep this on a screen, just paused and take a pen and paper and work out by yourself. Then you should be able to devise this one. See, I have devised the whole function by discussing each and everything, right? So you should be able to devise like this. Now this will help you to devise an algorithm for any problem, right? No doubt, initially it may take some extra time for you, much time for you, but slowly as you are in practice, then you can quickly answer these things. So this needs your practice, that is more important. So perform all these things, what I have explained here, the complete problem you do it by yourself once. Writing a function, coding it and seeing the output is not important. Framing a logic and procedure is more important. So you concentrate on framing this procedure by yourself. That's all with this procedure. Let us look at the second method for generating permutations of a given string. Second method is not much different. It is same as the first method. Most of the things are same. Just a few differences are there. So let us discuss those differences. Already each and everything in detail I have explained in the previous video. Just quickly I will show you the working and also I will write on the function based on the working. Right? So here is a given string. We want the permutations, right? So you know well about the permutations, so I don't have to explain you about the permutations. Now let us look at the procedure quickly. This procedure will be using swapping of the letters, right? So we don't need extra array. We don't need an array to know which is included or not included. So this is just by using swapping. So let us see the procedure directly. See, the first starting array is given. So we know it is having A, B, C and null. So we need the starting index and ending index, that is the length of a string. So we'll take this as low and this is high, right? So I'll start with this. And this is array S. first call. In the first call, what we will check? We will scan through a string in each call, right? We will scan through it. So for that, I will be at first letter. So when I is at first letter only, so I will not show null now. A, B, C, and the low is here and high is here, I is here. So swap the letter at L and I. So it is swapped with itself. And call again. Call again. Then A, B, C, A, B, C. Now when you are calling again next time, L should be on the next letter, H. See, L is on 1 and H is on 2 only, right? So call this one. Then start scanning. From where? I starts from here only, right? You don't have to take this one. So swap I and L. So B is a swap with itself. Nothing will happen. So you don't see any changes in this first pass. Then call again itself. So here is A and here is B and here is C. L and H. Now I. Now right now L and H, low and high are equal. So don't swap anything, print this result. So we will be printing here, print this one, right? Now go back to previous call. So previous call, I was here, right? So next call, in the previous call where A, B, C, low was here, high was here, I was on this place. So now I will move to next. I will move to next. So what we were doing? Swapping I and L. So L is here, I is here, right? So swap, like if I say 0, 1, 2, L is at 1 and I is at 2. Interchange. So this will become C and this will become B. Right? Then call again. Call again. Next call, again A, C, B. Right now it is A, C, B. It's not A, B, C. Same string, right? Same string. And where L will be? At the next place. At the next place. So L and H, both of them are here. Now when they are equal, then do what? Print. Go back to the previous call, right? And swap them back to their original places. Alright. Now can I continue further? No, it is end because it has reached H. It is going beyond H. Go back to the previous call here where I was at this one, right? At this 0, first letter. Then the next call. L is here only, H is here only, and A, B, C. See, the call is same actually. Call is same, but I will be on the next letter here. I is on the next letter. So in each call, we have to scan through the entire string. So I was in the beginning, now I is on 1, right? Then interchange I and L. So this becomes B and this becomes A, right? Then call itself. So when it is calling itself, this is B, A, C. L will be on the next letter. Start I from here. I is on the same place. No scanning is done. Then call again itself. Then A, B, B, A, C. This is. Then L will be on the next one. So as these are equal, don't do anything. Just printf. Printf. And go back. So we have done it when I was here. So the next is B, A, C. Then I will be on the next letter where L is here, H is here. So interchange. So this becomes C and this becomes A. Right? Then the next call. Here B, C, A, L and H are same. So just print this one and go back. When it is going back, it should copy the things back again in the same places. So it should be A and this should be C. So this is AC and it's going back. So it should copy the things back again. Right? A here and B here, and it should continue upon the next call. Next place. So this is how it works recursively. I will write down the procedure. Then you look at the tree once again. Void, I will call the function name as PERM, and it should take a string and it should take low as well as high. Next, I need a variable. Then now here I will write on a for loop for scanning I from low, I is less than equal to high, I plus plus. Then inside this swap a string from low to I. See, remember we were swapping the alphabets wherever I and L are pointing. If they are at different place, we can see the swapping. If they are at same place, no effect of swapping. Swapping will be definitely done. Then after that, call itself again by PERM, same string, then passing low plus 1 and high as it is. call again for the next level. Then L is in, right, L was here, the next L is here, then L is here. So when it is coming back, it should swap alphabets at S of L and S of I. We are putting back the letters as it is, right? This was BA, then again it became AB for the next pass, right? Next pass. That's all we have to do in this for loop, and this all we have to do if low is not equal to high. If low is equal to high, print a string. So here, if low is equal to high, printf a string S, right? And all these things should be done, else all these things should be done. So here I write it as else. So this is inside else. And this is the end of the function. So that's it. This is a simple function. So you can trace this one and again generate a tree by yourself. And again, your work, paperwork is more important. And if you spend time on this one, then the problem is yours. Solution is yours. Right? Otherwise, just you have heard it once. That's it. And the coding is not much important here. Writing the program and looking at the result is not important. This contents you can find anywhere. Just you Google it, you can find the contents. But understanding it and tracing it and reframing it or making changes in this one by yourself, that is the more important, right? So if you work on this one, then you can find a solution for any other problem. So that's all.